Keynote speaker. Dan and I have known each other for a while. He and I both worked on major constellation programs. I worked on the Iridium ground station back in the early 90s. He was busy working on the Global Star ground station in the early 90s. Both of those were successful launches, and at the time they were the largest private company constellations of LEO satellites in orbit. So when we first met, he had started at NASA in 2001, and I was still working for the same company, but not working on the Iridium ground station anymore. And we got to trade notes on, well, you know, here's the problem of scaling up to enterprise scale solutions with tens of satellites, and of course now we're talking about possibly thousands of satellites in these small satellite constellations. And Dan has since moved on to a number of missions that you might be familiar with. He's been a program manager on Hubble Space Telescope. He's participated in the very successful GOES weather satellite system. NASA was the procuring agent for the satellite for that mission, and has 40 years of experience as a ground system developer. But he's here today to talk to you about how we're doing things different now than we did as big space 30 years ago. So, Dan?
We're 40 years ago.
40 years ago.
Hubble in 1980 for the ground system still had punch cards and card readers. So we've come a ways. Okay, so really not that long ago, if you talk about CubeSats, the history really started with Cal Poly in '99. Specifically, it's a way to increase access to space for universities. Okay, so that was the premise. Design a 10-centimeter cube that's a form factor, and watch what challenges that leads you to and what you can innovate because of that. But that start, then it took off. Not only obviously for universities, but it's worked this way now to big science with NASA, and there's reasons for that. If you can launch a lot of small CubeSats, you can have temporal coverage, you can have spatial coverage, you can replenish technologies over time. There's a lot of advantages to using lots of small satellites. But it's also gone down. You heard Blair High School's here. Are they here? Anybody from Blair? All right. My wife went to Blair, but there was no CubeSat program at the time. It was 1973. But today, I know friends that their hobby club is launching their own CubeSat. High schools are launching CubeSats, universities, and now commercial sector. You see some of the imaging satellites. A lot of folks are saying this is the most cost-effective way to go, with many of the advantages, again, of continual evolution for space sensors. So the small size, though, why did we need a Hubble Space Telescope that's the size of a school bus? Why is James Webb Space Telescope that's taking its place the size of a tennis court? Those are not going to shrink down to a 4-inch cube. But the challenge of that 4-inch cube has really worked on a lot of our other sensors. There are more and more sensors now that the investment has been made, at least on the NASA side, to get things to fit in that little box. It's challenged the sensor developers, the scientists. It's come up with new enabling technologies, that they come up with new science ideas, how to study things from space. If you can watch the Earth from all angles at once versus one retrace every couple of days, there's an awful lot you can do as far as looking at the world's changes, measuring just the carbon footprint, or those type things. So, but to do that, it's not just making a smaller satellite. What if you had a smaller satellite, but you built it the way you always built satellites? I went to a design review of one of NASA's first CubeSats, probably 5 or 6 years ago. It had at least this many people in the room. of people that were working on it. They were using their old approaches on a new type of satellite. So we had the thermal engineers, the mechanical engineers, the electrical engineers. Each of them had their leader and then their support teams. Each had their simulations groups, and the room was packed. So just saying, let's go to something like this doesn't do it. You have to change how you attack the problem, how you address it, how you design it, all of that. How do you control a lot of satellites? Another meeting I went to in a control room, we were talking about what if we launched 100 satellites? And like Brad said, he and I came off large constellation programs. So we're used to, 50 satellites to me is not a big number. We mentioned 50 or 100 satellites, and somebody in the room spoke up and says, there isn't even room for 50 or 100 chairs in the control center. Because they're always used to, you dedicate people to each satellite. Okay, so we've had to change the ops approaches. How do you build the control centers? Well, in the past, if we had 3 satellites, they'd line up 3 rooms and make 3 control centers. The CubeSats were not going that way. What can you do for very little money that will handle lots of satellites? So one of the big areas that's helped us with that is standards. So we have standards, we'll talk about more of those, both from the OMG and I'm going to talk about CCSDs as well. The OMG and CCSDs are not competing standards groups. They're both space related, but they have different roles they're playing. And so for NASA, we're heavy users of both of those. So we'll talk more about that. So when Brad asked me to talk about CubeSats, I went around the office to some of the folks working with CubeSats and said, tell me, just what comes to mind when you think of CubeSats and standards? And I'll start at the bottom. Here's what I used to get. Yuck. It doesn't apply to me. My mission's special. I'm in a hurry. I don't want to learn standards. But especially for CubeSats, they're seeing the value of doing things in a consistent way. So you can bring in existing products. You can know how to process data. You're not having to do it from scratch. So now, the top is the type comments I was getting. Why wouldn't they be using standards? People are starting to take for granted that for lower cost efficient systems, you're going to be using a number of different standards. What do you mean? CubeSat is itself a standard? And yes, it's not a CCSDs or OMG, but coming out of Cal Poly is very well defined. There's groups that want to use open source control centers, open source software. And again, if you've aligned with existing standards, there's a lot of products out there to help you. And really, some folks said there's no difference between the small satellites and the big ones as far as the benefits they see from the standards. So this is just to trace kind of around when you look at a full mission. You have your CubeSat form factor, which is great. It's standardized. You can go to CubeSatShop.com online and order yourself the structure for CubeSat. Okay, you have common components, cameras now, solar panels, all sorts of things that will plug into that. So those are coming along. That then pushed the launch industry. It used to be, we would count on $60 to $100 million to launch our satellites per satellite. You'll see with Brad's charts, when you look at CubeSats now and you hear about 30 or 40 or 50 being dispensed now off one rocket, the cost has come way, way down because a business case has been made by everybody who wants to build CubeSats for these launch companies to say, okay, let me take on that next piece of the challenge. So launch access has come way, way down. Data access is the next one that's really evolving quickly. We've had issues at NASA and elsewhere. If you launch a lot of satellites and they all need antennas to come to the ground, if CubeSats are very low in power, so you want a good size antenna, all of a sudden you're going to overwhelm the set of antennas we've always used. So what are solutions to that? So there are groups from KSAT with over 200 antennas on the commercial side, to universities doing their own, to we're going to hear about coming up this afternoon, Amazon Web Services as a great data access as a service type approach, moving things straight to the cloud. So they are now beginning to address really the next the next part of you keeping the cost of the CubeSat programs down. Then you get into mission ops. This is kind of the main part for the OMG. They have C2MS, and we'll talk more about that today, and XTCE, and the ones that Brad talked about. There's now commercial products and open source products that support those to help you build your satellite control centers. Outside, NASA has a demo table showing off, it's a 165-pound control center. Okay, there's enough power in it that if I needed to support launch with 10 additional thin clients, there's enough power in the box out there to do that. Okay, so we're getting to where through these standards and through available tools, we can get the mission ops costs down. The one out in the hallway showing 3 satellites, you can just as easily be doing much more. But those are all needed, but then we still build back up when we look at enterprise type systems. As we look at large collaborative efforts, many satellites, in our case for science, the DoD looks to benefit the warfighter, different situational awareness. If we have lots of satellites doing collaborative science, maybe with the Europeans or the Japanese, the way we work at NASA, we got to start thinking about how to grow this into a larger enterprise. Okay, and there the standards, not just for how you integrate your systems and describe your satellites, but how do you talk and exchange messages between other organizations? How do agencies around the world work together to do things? This may sound odd, but we have regular meetings with the Chinese and the Russians on defining new security standards for our satellite data. We collaborate with them on our security stuff. So we meet regularly with all the space agencies of the world, trying to say what gaps are there in standards that we can help fill in. So there's 2 primary space standards organizations. The OMG, I give them preferential treatment because that's who's hosting this. We're here today. But they don't cover all the bases, but they're not at odds with CCSDs. So the OMG as a group's been around since the late 80s. They have the key standards that Brad mentioned. As a ground system developer, I look to the OMG a lot. They help us in how to do messaging between systems, how to control local components, how to simplify integration if I get products from different places so that they can kind of drop in place. Really, the open architecture approaches are all embodied for building ground systems with the OMG standards. CCSDS has a little broader scope. It's also been around since the 80s. They look at everything from onboard algorithms for data compression, because things are a little different with some of the space images, to the space-to-ground communications that don't work as the same way the internet works. File transfer standards through space can have to work differently than a normal FTP. Optical communications, they're working on that. So they do a lot on the space-to-ground interfaces so that around the world I can go down to just anybody's antenna from another space agency and they can actually interpret the data at the packaging level and get it routed back to them. So we all communicate along those ways. They actually have a database where they allocate what we call a spacecraft ID for all the big missions out there across the countries. So if you get a packet of data from mission X, it'll have in its header its ID issued by the CCSDS group. There's about 1,000 missions right now in space using the CCSDS standards. One more on CCSDS. I forgot it had the silly animations. So where within OMG, there's a group called the Space Domain Task Force that focuses on space. Within CCSDS, it's all about space, but then there's section cordoned off into 6 what they call areas, and a total of about 24 working groups. So there's a mission operations and information management area on the far right that really addresses the closest to matching up with what the OMG does. But again, the emphasis of CCSDS in that area is how do space agencies work with each other. It's really not about how to build your own system, how to get your products to integrate with each other. So there's a different role there. But you'll see the breadth of standards combined between OMG and CCSDS for those that want to work on everything from small missions to large ones. If all the CubeSat folks came up with their own structure for the messages going from space to ground, or how to command, in different packet sizes, well, then you have the problem of how do I build my custom software on the ground to handle that. The more you go to the common approaches, the more the tools for all the way down the line are in place for you. Some of the new areas here, optical comm, when you're talking hundreds of megabits or gigabit per second, with error correction, wanting to do that for the moon or Mars, there's some specific challenges. How do we all control and exchange information with ground antenna sites so we can manage those? And on, so CCSDS. So as we move towards an enterprise, and Brad had prompted me with some questions, what happens when we start moving to hundreds of satellites? And there are groups that are talking 1,000 or more satellites now. What do I do as far as the number of human operators and how that works? It's a pet area of mine, so we could talk for a long time. I could put 50 charts in here and get a great talk, but I'm almost out of time. So I took the easy way out. There are ideas, think of a herd of satellites, like a herd of cattle, where the farmer and the rancher manages the herd. He doesn't go out looking for cow 1 and cow 2 and cow 3 each time. So some of those concepts are being applied now to how to fly satellites. Think of other things on your car, anything complex. It has a lot of pieces. A constellation has a lot of pieces, and there's just air gaps between them all. So there's lots of folks using different concepts there. But some of the short answers are common, well-defined interfaces, so that even if different folks are sharing the job, they can communicate with each other and we can aggregate up to an enterprise. The new ops concepts, again, at NASA, I think we look to the commercial sector. They're leading the charge for how to do these large constellations. NASA is experimenting with small groups, 3 satellites, 5 satellites, are sometimes challenging, but we're watching the commercial sector go up into the hundreds. As you look at new architectures, lots of things are there to help us move along. The open architectures, the data sharing, the mixed vendor systems. Mixed vendor systems meaning I can take some products from Kratos and Peraton or homegrown, a few that I want to add myself, and get it all work together because I have standards interlacing. Cloud hosting, and more. We're looking at that right now. We're dabbling in it, but I think we all think in the next couple of years will be a primary approach. Last 2 charts then is what other standards do we need? Again, between the two standards groups, we are looking for help from folks like you on what are the gaps we can help fill. U.S. Air Force right now is trying to do a very big initiatives to tie all their future systems to one basic approach. The OMG is very active with them on developing new standards or modifying what we have or showing what standards exist so they can go down that path. OMG, we've talked a little bit about CubeSat reference model. Should we have a standard vocabulary? Simple display page exchange, automatic generation of display pages. CCSDS is looking at how do you do that example of spacecraft IDs if you suddenly have thousands of satellites. Turns out they recently ran out of numbers. They're trying to figure out what to do. Nobody, same way, what they said, how many personal computers would it take for the country? A couple dozen. Same thing. Nobody ever anticipated there'd be tens of thousands of satellites coming up. Some other areas of consideration that have come up recently, licensing. The idea that each person, each CubeSat, has to go through a whole process with the FCC or State Department or whatever prior to launch. That model breaks down. with CubeSats. We've talked, I am the government, so I am here to help. We've talked to the other groups that are there to help. Their whole organizations were designed around the 3 to 5 type applicants a year. And now they've raised to us, what if every high school, every advanced high school honor science program with a senior project wants to do a CubeSat? The government policies right now aren't set up for that. There's talk about how to modify that. And our guys, where people want fail-safe, want things to last for a long time, are all concerned about what we do about part certification, this CubeSats, because it's growing out of the university realm into ours. So the last chart, like a lot of people do, is terminology. So I just put up 2 charts, two new terms, reinventing the wheel. And basically the idea that building CubeSat missions without standards really is like inventing the wheel. The wheels are out there, the parts are out there, the standards are out there now. If you use them, and we're going to hear more about that today, you're way ahead of the game. And the other is commodity. The reason for that is as we move to standards, and we've seen this in a lot of areas, there are now products out there, multiple products using the same standards. You can take your pick, and whether it's based on cost, we got people who like the color of the background on one better than the other. I'm not going to critique your rationale for picking one or the other, but what that tells me is these products are becoming commoditized. You can buy them and put them to use. If it becomes routine to just go online and buy yourself a CubeSat structure, it's become a commodity. And I think what we're seeing across the CubeSat realm, supported through standards, is aspects becoming commodities, not just in the structure, but all the way through the system, from launch and mission ops and system development. So that's really the themes I had. Please don't reinvent the wheel, and this is where I see us all headed. Thank you.
Okay, for the next phase, I'm going to introduce my Space Domain Task Force co-chair, Luis Rodriguez from Emergent Technologies, and he's going to moderate a panel on enterprise space. We have a number of panelists that are, essentially experienced with standards in their organizations and applying those to the missions, some of which are very large missions and multi-satellite. So if I could get the panel to come on up, and then Luis will come and moderate that panel for us.